All right, hi everyone. This is our video for task 11. So we're going to look at vectors today. So vectors, and you might know some of this from physics, anyone that's taking physics, always starts at some initial point and ends at some terminal point. Any vectors that have the same length and direction are all considered equivalent. So each of these vectors, even though their initial and terminal points are different, they all have the same length and they're going the same direction, so they would all be equivalent. Now you denote a vector often with some single letter, so vector u, vector v, vector w, etc. So if we would want to see whether or not these are equivalent, we would first want to see how much are you going up and over. So each of those we are going up 4 and over 3. And so that means by Pythagorean theorem, they have the length of 5, the magnitude of 5. So they're going the same direction, up 4 and over 3. They both have a magnitude or a length of 5, so those would both be considered equivalent. So vectors can often be written in what's called component form. Component form is rewriting the vector, so imagining if it had started at 0, 0. We write the component form with these that look like less than, greater than signs on either side. Okay, but that tells us that the vector is in component form. So these, because each of them we went right 3 and then up 4, if these vectors had started at 0, 0, they would have then terminated at the point 3 comma 4. So that's where that component form is coming from. So a few other examples that get a little bit more challenging. If we want to write this in component form, notice from our initial to our terminal point, we went right 7. That's why we have 7 here. And then we went down 5. That's why we have a minus 5 there. To put this in component form, we've got a 45-degree angle, so we can think of a 45, 45, 90 triangle. Normally we'd have 1, 1, square root of 2. So we got to figure out what did that square root of 2 get multiplied by here to give us 6. So I wrote that as d square root of 2 equals 6. Divide the square root of 2 over, and then if you rationalize by multiplying top and bottom by square root of 2, we get that 3 square root of 2 is what we must have multiplied by. So each of the ones get multiplied by 3 square root of 2, but if you're going left, that's got to be negative. So this means we went left 3 square root of 2, and then up 3 square root of 2 to get to our terminal point for our component form. And then the last one, say we've got a 20-degree angle, reference angle in the third quadrant. We've got the magnitude of that is 4. Well, we can set up our right triangle, and we could find the x part. We could just do cos of 20 is x over 4, so x is 4 cos 20. But it was in the third quadrant, so it should be negative, so you have minus 4 cos 20. Pretty much same idea to find the y. We would just use sine, though. So that's one way you can write the component form. Or you could have it and just leave it as cos of 200. So you could do 4 cos 200, 4 sine 200, and by leaving it as 200, that takes care of the negative sign all by itself. So either of those would be correct for the component form for that vector. All right, so you might want to take a second and write down each of those formulas, each of these ones here. And everything else in these videos, if you want, you can, it's up to you if you want to write stuff down or just follow along, and then you can always reference back the video as you're doing the practice problems. So the first one is to determine our magnitude. It can also be used to determine the speed of the vector if it has representation of some real life situation. Some of our vectors, we just add the first parts, comma, add the second parts. Same thing with subtraction. The next one, the k, this is what's called multiplying by a scalar. And essentially you can think of it as whatever that constant is distributes through to both parts of the vector. And then the last one's called a dot product. In a dot product, you multiply the first parts together, multiply the second parts together, and then add them together. And that gives us some single value for the dot product. So some examples over here, this is saying we're going to multiply the u vector by a scalar of 2 and then add them together. So multiply the negative 1 by 2, we get negative 2. Add it with the 4, we get 2. Multiply the 3 by 2, we get 6. Add it with the 8, we get 14. This one we're going to take half of the v. The half is our scalar for the v, and then we'll subtract them. So half of the 4 is 2. Negative 1 minus 2 gives us negative 3. Half the 8 is 4. 3 minus 4 gives us the negative 1. And then this one says we're going to take half of the v first, which will give us 2 comma 4, and then we're going to find that magnitude. So we'll do square root of the first part squared plus the second part squared, so that gives us square root of 20, or in other words, 2 radical 5. So say we wanted to find the angle between two vectors. A couple ways we can do that. One way is you could do law of cosines. So to do law of cosines, you got to imagine we connected the terminal points of each of those vectors. This first vector here, it's an up 2 over 5. So if you do 2 squared plus 5 squared and take the square root, you get that's radical 29. This one, similar idea, you got 5 and 1, so we get radical 26. And this one here, this would be going down 3 and over 6. So 9 and 36 gives us radical 45. So if we wanted this angle here in law of cosines, we would have the side across from it squared is equal to the sum of the other two sides squared minus 2 times each of those sides that are not across from it, cos of c. You could subtract those over, divide by this, do your inverse cos, and you would get the 79.509 degrees. One way that might be a little quicker is think of these as two separate right triangles. This right triangle here, from this angle, opposite is 5, adjacent is 2, so we can do an arctan of 5 halves. This angle here, opposite is 1, adjacent is 5, so you can do an arctan of 1/5. Just add them together and you get 79.509. And then there was a way you saw last year with Mr. Delands. You could do inverse cos of the dot product of the two vectors divided by the product of the magnitude of the two vectors, and that would give you the same thing as well. All right, just a quick application question. So say we've got an airplane, so it's flying 500 miles per hour, okay, due east. That speed is the magnitude. That's why that 500 is labeled there. There's a 70-mile-an-hour wind that's going 60 degrees north of east. This means you start at east and then go 60 degrees north from there. So here's east, 60 degrees north. Again, that speed, that magnitude is 70. We'll put the 60 in there. And we basically want to know what's the resultant path of the plane. And we want to know the speed and the direction. So first we want to find a vector in component form for p. So we went 500 right and none up, so 500 comma 0. For the wind one, we have a 60-degree angle, so imagine you make a right triangle. This usually should be 1 square root of 3 and 2, so that means everything got doubled by, or multiplied by 35, since we have 2 times 35 to give us 70. So this is 35 radical 3 and then 35, so we get our component form vector of w. Our resultant vector is just those added together. So add the first parts, add the second parts. And then to find our speed, well, that's just the magnitude of that resultant. So we've got the square root of the first part squared plus the second part squared. So it gives us that many miles per hour. And our direction should be an angle with some label on that angle. So the way you can think of this is you've got your resultant. Think of it as the hypotenuse of a right triangle. So I kind of drew down this dotted black line here. This base here is the 500 plus the 35, or in other words, the 535. This height was the 35 square root of 3, so we can just do an arctan of the opposite over the adjacent, and it gives us that. Now that angle, we were at east, and we went up some, so it's north of east. If you said east of north, that would be starting up first and then going to the right. So this is north of east. And that's it for this video.